What is a vortex? It's pretty easy to imagine, I guess. Just bear in mind a rotating flow, like a whirlpool in a river. But an accepted and universal definition of vortex is still missing. This is because vortex formation can happen with different fluids, around different objects, and also at different scales. Small-scale vortices of the order of millimeters can be found near the wingtip of an insect, while large-scale vortices, well, do you know the great red spot on Jupiter? That's nothing else than a huge vortex, 1.3 times as wide as Earth. So in this wide range of different scales and phenomena, is it possible to come up with an exhaustive definition of vortex? Or even more ambitious, can we define a universal law to fully describe vortex formation? Let me show you an example. If you look on the left side of the great red spot, you will see an amazing wave structure, which is a series of smaller vortices. Keep them in mind. Now, coming back on Earth, when an object interacts with a flowing stream, a thin layer of fluid appears and it rolls into a vortex. This vortex grows in size and strength up to a certain point when it poof, separates and drifts away. Before the separation point, a series of smaller vortices appears next to the first one, exactly as it happens on Jupiter. So different scales and even different planets, but still similar behavior, which can be described by the same laws. My work is to experimentally study vortex formation around objects with different geometry and motion. From this experiment, the first step is to extract an empirical law, which is able to predict the vortex size, the vortex strength, and the separation time. What is really fundamental for us is that this formula should be valid for all the experiments we performed. Then, using this formula, the second step is to reverse the previous problem and find which geometry and motion an object should have to obtain an intended vortex and control it. Do you know the importance of bees for life on Earth, right? Be aware that bees can efficiently fly to transport pollen among flowers because they know how to control vortices with their flapping wings. So imagine the potential if we were able to mimic the bees' vortex control to improve engineering systems such as drones, especially at smaller scales. In the end, we went from vortices on Jupiter to the one near drones and insects. Making a connection between all of these will be my work for the next 3 years. Thank you very much.